Last lecture I was discussing first about the oxyacetylene or oxy-fuel gas welding techniques. At the end of last lecture I was started about the SMAW process, and I have completed till the classification of different flux cover electrode used in SMAW process in details. There I completed two different categories of flux coated electrode. One is called cellulosic electrode and another one is called rutile electrode. And another categories of electrode also I will discuss in today's lecture. Apart from that, I will complete the rest of the things related to SMAW process, that means shielded metal arc welding or shielded manual metal arc welding process. So, last lecture I was discussing about cellulosic categories of different electrode used in SMAW process. One is called cellulosic electrodes, another one is called rutile electrodes, and third one is called basic electrode. So, I have completed these two, cellulosic electrode, rutile electrode. What we observe generally, rutile electrode is a general purpose electrode. What is the application, what is the basic feature of that things I have discussed in details in last lecture. And I was also discussing about cellulosic electrode in last lecture, that there what we observe that is a very good electrode, but it has some drawback also, because it has mechanical property which is good in nature compared to this rutile electrode. And in cellulosic electrode, what we observe that it has some drawbacks, that means when it is burned, it produces generally hydrogen gases. So, this hydrogen gases high temperature, what we observe that in high temperature it is converted to hydrogen ion. Generally hydrogen ion at high temperature, its volume comparatively lesser than hydrogen molecules. So, at room temperature, when this hydrogen ion converted to hydrogen gases, then its volume increase. So, then this trapped intermolecular trapped hydrogen ion, once is converted to hydrogen molecules, then its volume increase. Due to that, there can be occurs embrittlement or embrittlement of the what is called microstructure of that material, and due to that embrittlement of this microstructure, there can be chances of crack propagation or cracking of welded heat affected zone. That we observe in last class. That is the main drawback of cellulosic types of electrode. So, actually what we observe that you may think, so why these three different electrode is required? Because three different electrode is required, or why this electrode is gradually developing and developing, that types of things you can think. The think of this, because what happens, it has seen that all the electrode, the one electrode cannot do all the purpose actually. So, that is why what happens, wherever there will be some requirement, there will be some research and there will be some new development. That is why this new types of electrode is coming into picture. Nowadays also you can see that there is different types of electrode oriented research work is going on for different purpose, and different types of electrode is also developing. Now, that is why the different types of electrode, but these are electrode which are widely used electrode in the case of SMAW process, that I am discussing here. So, the third categories of electrode, because what we observe that cellulosic and rutile electrode have some drawbacks, and which are drawbacks, or we can say some sort of feature which is required for some other welding purpose that we are not getting. That is why another electrode is developed. So, what happens, one of the electrode is like basic electrode. In basic electrode, here also this electrode generally do not provide, actually what happens in this electrode generally contain calcium carbonate and calcium fluoride, these two component present with these flux constituents. So, due to these two components present in flux constituents, these have some very good properties which I will discuss subsequently. This electrode do not have hydrogen generation. Actually, that is why it is referred to as low hydrogen electrode. This is the main characteristic of this electrode. This electrode generally makes the slag more fluid than that of rutile coating, because you see we have observed generally rutile have fluid types of slag composition, that means viscous types of slag it is produced, and its bit shape also depends on this viscous property of slag. There we observe that its bit shape also quite good in case of what is called rutile types of bead appearance is good in case of rutile types of slag, but here it is more fluid than the rutile coating. And here one thing you should keep it in mind, here slag is fast freezing type, that means immediately it solidify. Actually its solidifying rate is very fast compared to rutile types of. Due to this solidifying, or you can say fast freezing characteristic of these types of electrode, is suitable for vertical and overhead position. You see, you have observed that the other electrode also able to do positional welding, like what it's called cellulosic. We have observed that it can use in vertical downhand properly, but that will not be suitable for overhead welding process, whereas we observe that rutile is suitable for horizontal as well as vertical position welding, but what it's called, that is not also suitable for overhead position. But due to this fast freezing characteristic of these types of flux, as it solidify immediately, and its viscous characteristics, that means more fluidous than that rutile electrode, and fast freezing characteristics, this you can successfully use in overhead position. This overhead position means due to this fast freezing characteristics of slag, here it solidified rapidly. That's what happens, chances of falling down of molten metal from overhead is less. So you can successfully use this what it's called electrode in overhead position also. So you see it has some extra types of advantage than other welding electrodes. Now this is the basic feature of this, that means feature of basic electrode. Generally here weld deposit with good mechanical property. What we observe, though this what it's called rutile electrode is also viscous and liquid property is there, but its mechanical property is moderate in nature, but here generally mechanical property is good. Here it adds low hydrogen content in weld deposit, as there is no hydrogen content generally here compared to cellulosic also. It has what it's called low hydrogen content in weld deposit. That's why generally this has very good quality application, this types of electrode is used, that I will tell subsequently. Here it is relatively fluid slag. Here generally as it is fast freezing type, due to this rapid solidification of slag, here generally bit profile is comparatively poorer, poorer, that means poor bit profile here we get. And here another thing, due to this fast freezing characteristic and poor bit profile, here slag removal is little bit difficult than other electrodes. Here this electrode is very suitable for thick steel with higher carbon content also. And another things we should keep it in mind, this generally weld metal has excellent mechanical property, especially impact property. Once you do welding by using this electrode process, impact property is very good. That's why here it's particularly impact property. Once you do using this welding electrode, then your welding has excellent impact property. Now these basic electrodes generally are useful for what I have already told you, that for high quality application, which call for low hydrogen content, because as it has very low hydrogen content, or you can say here hydrogen is almost not available. That's why what happened, it has generally very high quality application it is used. The moisture content of the electrode coating should be kept to a minimum. This you should keep it in mind. Here once we do the welding by using this electrode, moisture content should be minimum as possible, then your weld quality will be good. Here one thing you keep it in mind, that once the electrode exposed in open weather, then what happens, this flux have a tendency to absorb moisture from atmosphere. So what happens here, to avoid this thing, generally once you go for using any electrode or these types of electrode, basic electrode, you should dry it before doing welding. That's why what happens, because these types of flux have a tendency to absorb moisture. Once there will be moisture in the flux, then during welding it generally burn and can produce hydrogen. That hydrogen again can do that embrittlement effect and cracking effect in weld joint. That's why whenever you go for doing welding by using these types of electrode, you should dry it properly, so that moisture should remove and it should be as minimum as possible. That's why welding of HSLA steel. HSLA is a very sophisticated type of material. Its full form is high strength low alloy steel. It has strength is high, but in this material there is different alloying components are there. Alloying means different, a small amount different material is added in this steel actually. This is a type of steel, high strength low alloy steel generally. A is for high, A is for strength, L for low, A for alloy. So, this has wide application in different industry like shipbuilding industry and other industry also. It has different application, a thermal power plant, or not only thermal power, generally in shipbuilding industry it has wide application. Apart from this, it has also application in different power plant application also it has there. Once you go for doing this HSLA steel welding, generally basic types of electrode is best suitable for this. And once basic electrode is suitable, and so when we go for using this basic electrode for doing these types of steel welding material, then what happens here, generally additional baking generally is used. See, additional baking immediately before welding generally is used. What is baking? Baking is a process actually, we can say. Baking is a process by which electrode is dried. That means electrode is dried by baking operation. Here what happens, there is a dryer there which is either some sort of electrical types of furnace or some sort of other means also that their dryer can be. It is a small container which continuously heating up mechanism is there. So, what happens, once you keep the electrode over there, then whatever the moisture and other things will be there, that will be heat up and that will be removed. That is why once we go for using HSLA, this type of drying operation is immediately before welding is done. So, that what happens here, the moisture absorption will be removed and the weld quality will be very good. That is why directly, that is why this HSLA, in this case electrode used directly from dryer, and generally as it is directly from dryer and it is used for welding, as for that reason further eliminates possibility of moisture absorption. That means that moisture content will be eliminated more or less fully. So, that is why this type of baking operation is used immediately before welding in case of HSLA to remove moisture content and remove this possibilities of hydrogen embrittlement. Application of this types of electrode, generally it is used for welding pressure pipelines, oil storage tank, shipbuilding industry, ships, that is ships, boilers, railway wagon, and this you can use at very high welding speed also. Also, this is well suited for repairing of steel casting part. That means this is also used for repairing. It has, this is a practical application of these types of electrode what I am telling here. Another types of electrode is also you can see once you will be in industry, that is called metal powder electrode. Here generally metal powder is a constituents of the flux. So, here generally it contain an additional iron powder in the flux coating. Due to this excess amount of iron powder contained in flux coating, it considerably improve the performance of the welding operation. How it is that I will discuss subsequently. Here this amount of iron powder in flux composition can varies from 5 to 50%. Generally iron powder is added generally to increase deposition rate and to improve arc behavior. This you keep it in mind. How its increased deposition rate and how it's improved the arc behavior, that I will discuss. In conventional welding electrode, whatever the electrode I told you, already discussed 3 different, their current is carried wholly by the core wire. Whereas with iron powder addition in flux, the coating become conductive near the arc. So, here this flux cover, as it is contains some iron powder, it's also provide some conducting path. So, here provide an additional path of current. So, as it is providing additional path of current, so that is why generally here arc tend to spread out and metal deposition takes place over a wider area. Here these things you keep it in mind, because here the conducting area is increases, due to this arc tends to spread out. So, what happens as the arc is spread out, so what happens, there is a chances of metal deposition area will be wider. So, as the arc area increases, we know because due to this extra conducting path or extra current flow through the flux coating. So, here definitely its current density will be decreased, because our cross sectional area is increasing. We know generally arc density, current density generally ampere per millimeter square, that means ampere per area, that is called current density, what I have already discussed. So, generally as the area is increasing, so current density will decrease. So, once current density will decrease, then penetrating force will decrease. So, once penetrating force will decrease, then what happens here? Less penetration will occur due to this excess flow of current through flux cover. Now, additional conducting area in this arc generally limit the current surge when a short circuiting types of take place. Here one thing you keep it in mind, as the current is flowing through this flux coating. So, what happens once the short circuiting will be taken place, then what happens, there is a chance of less current surge, that means current rise will be slow or less generally due to this higher conduction of current through flux coil. That is why generally what happens, so during short circuiting types of metal transfer, these types of flux coating is one way we can say good, because due to this less surge of current occurs in case of short circuiting types of metal transfer. Due to these things, what happens for this region, extra conduction of current through flux cover, what happens here, reduce the occurrence of spatter, provide a smoother and more stable arc, improve side-wall fusion and flatter welds. Why these things occur, that you understand, that because what happens, it generally increase the wider the bead area, or you can say wider the arc, so bead area. So, that is why a side-wall fusion also will be good. And what happens, due to this wider arc area, here bead becomes flatter. Now, here generally higher deposition rate in this metal powder electrode, higher deposition rate are achieved by increasing the iron powder content in the flux coating. But one thing you should keep it in mind, that means first slide itself about this flux coating, I told you here generally this range of means this metal powder should not exceed 50%, because what happens, if we use more than 50% flux over this, then generally this electrode behavior deteriorates. Because why this deterioration occur? Because due to this high content of what it is called metal powder in flux, there can be high flow of current, and due to this high flow of current there can be chances of high resistance. Due to this high resistance there can be what happens, there can be coating fuse unevenly. So, due to this what happens, this can that this electrode behavior deteriorates if it go beyond 50% what it is called metal powder content. That is why generally it is better to keep the metal powder below 50%. Okay. Here another things you should keep it in mind, higher deposition rate is actually achieved not only because of additional metal flux, but also as it contain additional metal flux in flux coating, it has a chance to carry more current, because due to this more current and additional metal in flux coating, so its deposition rate increases. That you should keep it in mind. Now, we will go for other constituents of what are that, because we are discussing about different constituents of SMAW process. There we observed that one constituent is electrode, another one is weld puddle. Weld puddle actually it is representing here itself. Generally weld puddle is a molten pool. Molten pool of what? Molten pool of base material, this electrode material and that flux. So, once this flux burn or melt, on this metal melt, base metal melt on the electrode melt, generally this form a molten pool. This molten pool is called a weld pool. Generally this always keep it in mind, welder manipulate the welding operation to see this weld puddle. It is well visible to welder, or generally which well visible this weld puddle. So, what happens to see this and manipulate the welding operation during welding. This is generally shown the picture of a weld puddle. Now, the other constituents is shielding gas. What I have already told you, shielding gas is generated due to the burning of the flux cover. That means once this flux cover burn, generally it produces some gases. These gases generally protect the molten pool, or we can say molten puddle from atmospheric contamination. So, that is why it acts as a shielding medium, that is shielding gas actually. Now, the solidified weld metal and another constituent, that also I was discussing. Solidified weld material means when this electrode material or weld material and base material solidify, it form a joint or connection between two pieces of base metal. So, here if the weld form a joint or connection between two pieces of base metal, you see this is generally represent solidified weld metal, or here a practical real view, a real picture of this solidified metal. Generally here one thing you keep it in mind, if the welding is done properly, this solidified metal can have more strength than the base material. Now, we will go for slag, that what I have already discussed. That means when the flax burn, generally then it is converted to slag, then it is generally called slag. Here one thing you keep it in mind, slag is a combination of flax coating and impurities from the base metal that float to the surface of the weld. It float the surface of the weld. Why? Because its volume comparatively mass lesser than molten metal volume. That is why what happens, it float over the surface of the molten pool. So, and it solidify, it is also solidify very faster than molten material. So, due to this what happens, it provide a solid cover over the surface of the molten pool. Due to this solid cover, it is also, I have already told you, it is also reduce the cooling rate. So, here due to this solid cover, here generally slow cooling is occur. Due to this slow cooling, what happens, here generally weld metal ductility also increase. So, here one thing you should keep it in mind, this slag can be chipped away and cleaned with a wire brush when hard. Generally this is required at the end of the welding, generally this slag removed from the welded portion by using a wire brush. That wire brush used to clean this slag. Now, here generally, so these are all about the different constituents of welding process. So, now we will go for what are the operator control variable, what are the different types of variable which can be controlled by a operator here. Actually, I am not discussing about what are different operating variable of different welding process, because what happens, what I have already discussed in at the end of the physics of welding topics. There are different types of operating variable, that is current, voltage, speed, everything that what I have already discussed in details over there. It has same function here also. So, in every welding process that I will not discuss. Here I will discuss some extra, we can say extra significant aspect, extra significant parameters if it is used for these types of if it is separate welding process, that I will discuss for a particular types of welding process. Here like this operator control variable, here it is very important variable for these types of welding process. One is called work angle, another one is called travel angle, another one is arc length and travel. So, these generally can be controlled by operator by this welding process, because it is a manual welding process. So, this is controlled by operator only. So, generally this I will just discuss subsequently and tell what is this thing in details, here I will discuss. So, first of all, work angle. Here you see work angle is the angle between the electrode and the work depicted on the left. You see this is the work which is depicted on the left, it is the angle between this electrode and this work. If the work here you see for different types of position welding, this angle is different. But for a flat types of welding operation, its angle generally within a range of 90 degree. That means its angle is 90 degree in case of flat types of welding operation. Here you see this is the angle 90 degree, this is the work angle for flat types of welding operation. Now, travel angle. Travel angle is the angle between the electrode, you see this is the electrode and the plane perpendicular to the work axis, or we can say perpendicular to the weld axis. So, is the angle between the electrode and the plane perpendicular to the weld axis. You see this is the weld axis. So, here generally a perpendicular, you see a perpendicular plane once you provide between this perpendicular plane, or you can say perpendicular plane and electrode, whatever the angle is there, that is called travel angle. This is also known as lead angle. travel angle you should know also what should be the range of this travel angle. Travel angle generally varies within a range of 20 to 30 degree, that here it is showing for these types of welding operation. Then arc length. Arc related thing I have already discussed in physics of welding in details, but here also what is the range of arc length are there, that you should know. Here the arc length is within a range of 1/8 inch or within a range of around 3 millimeter, or you can say within a range of around a diameter of the electrode. So here what is this arc length? Generally arc length is the distance between base material and electrode tip. Whatever the distance or gap is there, that is generally called arc length. Too short arc length is not good, or too high arc length also is not good, what I have already discussed in detail, because if the arc length become too short, the electrode will get stuck to the workpiece or that can be short out. Okay. So, if the arc length become too long, there is also chance of spatter, undercut, porosity can occur, that I have already discussed. So, here I will not discuss in detail about, but here just these are the things generally welder can operate or control. This operating variable can control, that is why I am telling here. Another one is travel speed, what I have already discussed. Travel speed means the speed at which this electrode moves through the welding per unit time. That what I have already discussed. Then through the welding line, that means how much length is depositing per unit time. That is generally called travel speed. Here generally too high travel speed also is not good, too low travel speed also is not good, that I have already discussed in physics of welding. So, it has also similar effect here. So, you see then we will go some what are the another different types of aspect or important aspect generally we found in these types of welding, that I will discuss one by one. So, first of all, in this welding operation, most of the welding operation this thing happen, but in this welding operation this has significant effect, and this is very frequently occur these types of phenomena, that is called crater. Crater generally it is a cavity which is developed at the end of weld due to shrinkage of weld metal during solidification. So, what is crater? It is a cavity which generally you see at the end of the welding operation, you will see there is a depression or due to shrinkage, or there is a cavity type shape, which shape is like this. You see, this is the end of the welding position. Here you see, here generally cavity type of shape is generally developed, or depression of or concave types of cavity generally is there at the end. Why this is occur? Due to solidification and shrinkage effect of weld material. These types of things generally occur. So, at the end of the weld, why this is occur? The operator break the arc. Due to this breaking of the arc, here this crater is generated. Here one thing you keep it in mind, this crater is a place where there is a chance of develop crack. So, always you should keep it in mind, you should eliminate or remove the crater during welding operation. Otherwise, there will generate crack or other thing, because due to this depression and other things, there is a chances of crack generation. So, that is why larger crater can cause weld cracking. Here it is telling actually larger crack can cause weld cracking also. Now, we will discuss how to fill this crack, how to eliminate this crack, that I will discuss in subsequent slide. So, first of all, filling the crater at the end of the weld, how we can do this thing, because in this welding operation generally this is a very vital aspects, or you can say vital types of aspects we find in this types of welding operation. So, how to fill this crater, that we should know. This we can fill by different types of way, or this you can eliminate by different types of way. One is called backstepping method. Here use a short pause or slight back step at the end of the weld to fill the crater. What is backstepping? Backstepping means a short move in the opposite direction of weld travel. That means wherever there will be some crater, you have to just move your electrode back and fill that things and do the welding operation again. So, backstepping, this method is generally called backstep, a short move in the opposite direction of weld travel and fill the crater. This is one way. Another way can be use a separate scrap material at the end of the weld and continue the welding operation till scrap material, and then crater is left on the scrap piece which can be generally detected or detached, which can be detached from the structure. So, here generally cutter is left on the escape piece, here it is cutter escape piece which can be detached after welding operation from this structure. So, these types of things you can see once you will be in industry. Actually, they are generally these types of different procedures generally used. Here to make the welding continuous, here at the beginning, at the end also there are two scraps material generally used. That means welding start from a scrap material, continue to main material workpiece, and after that also it continue to another scrap material. After that it can remove this two scrap material, you can remove, and you can get a very good weld quality, continuous types of weld quality. So, this is another method to eliminate what it's called crater in case of SMAW process. And crater is also filled by holding electrode. You see that holding angle of the electrode is around 10 to 50 degree with vertical. This holding the electrode at the cutter for an instant, and then normal welding proceed. That means wherever there is a cutter, hold the electrode for a particular instant or for a particular time, and then normal welding proceeds. This way also you can eliminate the cutter. You will see this cutter effect is very frequent when the workpiece is very long. Because why the cutter effect is very high? Because here generally while welding with long workpiece, a number of stick electrode are employed. So, when one finishes, then generally then welding is carried out with the help of other electrode. So, here there is a number of start and stop of welding operation are there. Due to this number of start and stop of welding operation, at the end of one electrode create a crater. So, what happens generally then we should eliminate this crater. How we can eliminate this crater for this long run welding operation, that I will just tell. So, here used a technique that is called restarting of the arc. So, this by using this restarting of arc we can eliminate what it is called crater effect in case of long run of SMAW process. There what happens, very good technique that is called restarting of arc. Here generally restarting of arc have some sequences that I will just explain. Once you use that types of restarting sequence, then you can eliminate the what it is called crater effect in case of long run types of welding operation. So, a crater generally form at a place where previous electrode complete and welding is to be started with a new electrode. That what I have told you. Generally here what is done, first of all before restarting what happens, slag is removed from the weld bead adjoining crater, and the weld bead and crater are thoroughly cleaned of the slag etc. First slag we have to remove near the crater region, then we have to clean it properly by using wire brush or grinding, by using grinding operation also you can do that things. After that you have to do the what it's called restarting, because if it will not be cleaned properly, then there is a chance of slag inclusion inside the weld material, that is also a defect. So, we should clean it properly. Then this sequence of restarting procedure is required to do. What is this sequence or restarting of weld are there? Here generally you have to generally tap the electrode away from the weld region. After that you see, so here after tapping you have to start the arc here. Immediately at the second step move the electrode to the crown of crater. After that this third step you see, this is first step, this is second step, and resume, then after that resume the forward travel and do the welding operation. So, you see, so first of all you have to start the weld away from the welding region by tapping method. After that immediately you have to move the electrode to the crown of the crater and resume the welding operation by forward travel, like this is step 3. So, if you do the restarting of the electrode by this way, then what happens, this crater will be eliminated. So, these are the different process by which you can eliminate crater from welded joint. This is very important aspect of SMAW process, you should keep it in mind. Okay. Now, we will go for weaving technique in SMAW. This is a very interesting and important aspect which is used in SMAW process. Generally weaving generally implies giving a side to side motion to the welding arc during transferring material to the joint to be welded. Here generally electrode is moved or oscillated from side to side in a set of pattern. So, generally this weaving operation is required to do where more material is required to deposit and weld bit shape required is wider. This types of weaving operation is required to do, especially for multi-pass where more material and wider bit shape is required or thicker section. These types of what it is called weaving operation or weaving technique generally used. Weaving helps to give better fusion on the side of the weld. This also not only widen the weld bit, it also gives better fusion on the side of the weld bit also. Here one thing you should keep it in mind, this whatever the weaving width should be in a welding operation, that should not exceed 2.5 times more than the what it is called electrode diameter. That you keep it in mind. Now we will see there are different types of what it is called weaving operation are there. So, in order to be sure of uniform deposit, it is necessary to use definite pattern of weaving operation. So, to sure of uniform deposit, definite pattern generally it is not do arbitrarily. There is different very definite pattern are there that we should follow generally for doing weaving operation. Here like this can be, here I am just showing this 6 different weaving operation which is generally widely used for during weaving operation. That is, one is called convex weaving. Here you see how the movement, these arrows represent the movement of the electrode, how this movement should be, movement of electrode should be there. This is called convex weaving. This can be concave wave also. Or we can say concave weaving operation. So, convex concave weaving operation. Here it is generally opposite to this convex weaving operation. This can be circular types. How these circular types you see, this arrow representing, here you see how it is generally continuously moving and how the circular shape is coming. So, this is called circular wave. Then another can be ladder wave, how this ladder wave is done. This is ladder weaving operation. This can be jagged ladder wave. You see at this horizontal position generally there is used some zigzag motion. So, that is why it is called jagged ladder wave, weaving operation. It can be triangular shape, how this triangular shape is there, that is also given. That means this arrow represent what should be the moving direction, how it is, it makes a shape of triangular in nature. So, this is another called triangular types of weaving operation. So, different pattern of what it is called weaving operation is there. So, once we follow this pattern of welding operation weaving operation, then we can get a uniform weld bit deposit. Okay. Now, we will discuss what is the advantage of this welding operation, what is the drawback of this welding operation, then what is the application of this welding operation in detail. Here you see this welding generally have different advantages. These are the following advantages we can observe in this welding operation. Like first of all, this welding is simple, portable and inexpensive welding equipment are there. So, here generally simple, portable and inexpensive welding equipment is used. Here another thing, both filler material, arc, molten metal, shielding generally are provided by electrodes. So, whatever the shielding here we are providing, every shielding of molten material, electrode, arc, everything is shielding by how? By electrode only, because it is providing shielding gas as well as flux or slag cover. Due to this generally it shielded the molten pool as well as arc as well as what it is called filler material. This can be used in the area of limited access. That means where a small space or limited area access is there, there also you can do the welding by this welding method. So, limited access position, in limited access position also you can use this welding operation. It has very low initial cost compared to other welding techniques. It has also wall position capability, because I have already told you by this welding operation you can do horizontal, vertical, overhead welding position. That is means wall position capabilities of welding operation you can do by this welding method. And this is a welding method which you can use most of the commonly used metal and alloy. So you see so many advantages of this welding techniques are there. Now we will see what is the limitation of this welding process. because we see where there is a advantage, there is some drawbacks also. What is this drawback? Generally lower consumable efficiency. Here whatever the consumable we are providing, its efficiency is lower. Difficult to weld very thin material, what I have told you. It is a stick welding. Generally what happens, during starting of the arc itself, there is a chance of what happens, melt through of that thin material is there. That is why it is difficult to weld very thin material, because there can be melt through of that thing. That is why it is difficult. This is a drawback of this welding process. This another thing, here stick is used, so very frequent restart will be there. If the welding length is higher side, then very frequent restarts also are there. And here one thing you should keep it in mind, here generally operator skill should be comparatively better than other welding process. So higher operator skill is required in SMAW process than other welding process, because here so many techniques, so many things is required to control, what I have already told you. Here another things you should keep it in mind, deposition rates are lower than other welding process like GMAW, that is gas metal arc welding or MIG welding technique. Why? That you should know, because here one thing you should keep it in mind, we cannot increase the current through the electrode as much as possible. Why? Because what happens, this electrode have a resistance. Due to this electrode, if the current flow will be more through this electrode, there is a chances of overheating of this electrode is there. Due to this overheating means there is a chances of deterioration of the flux cover is there. So what happens, so we cannot deterioration of flux cover, and there can be uneven breaking of flux cover is there. So if there will be uneven breaking of flux cover, then that creates some defect, that will not provide good quality welding. That is why what happens, here is a limit of current flow through the core wire are there. So we cannot increase current as we want. Okay. That is why maximum current that can be used is limited by the electrical resistance of the core wire. This you can keep it in mind, because excessive current may overheat the electrode, breaking down the flux coating. Due to this overheating of this what it is called core wire, there can be electrode breaking down. So what happens, which will deteriorate the arc behavior and shielding. So then your weld quality will be defective. Then we will go for application. You see, these welding techniques have a lot of application. In the sense, it is generally suitable for most of the commonly used metal and alloy. This shielded metal arc welding is used both as fabrication process and maintenance. It is also used in repair job. The process find application in the following industry, or you can say in following industry a lot, like in shipbuilding industry, piping joint, pipe joint, automotive and aircraft industry, building and bridge construction, air receiver, tank, boiler, pressure vessel fabrication. So it has different application of this SMAW process. So you see, these are all about this welding process. Generally in every welding process, generally this will be our sequence of pattern of discussion. Like first of all, in the there will be introduction of that welding process, then there will be setup of this welding process, then there will be the principle of this welding process, then there will be different important aspect of this welding process, and at the end there will be advantage, disadvantage and application of this welding process. And if there is any safety precaution, that also we will discuss. So here also in this welding operation there is some safety precaution in this, that you should keep it in mind. Generally in this welding process you observe there generate fumes and gases. These fumes, whatever the fumes and gases are there, that can be harmful to welder or whoever do the welding, that can be harmful. That is why always keep it in mind, keep your head out of the fumes, use enough ventilation and exhaust at the arc. Nowadays for doing this welding operation in shop, generally there is used some extraction system which extract that fume and other things. So what happens, there is a chances of less effect to welder are there. Then another so this is one safety precaution is there, that means keep your head away from the fumes or gases. Okay. Then second one, electric shock. Here there can be chances of electric shock, because what happens, if your bare body touch the electrode and workpiece at a time, then there is a sudden shock can be there, and which can be dangerous to the welder also can be there. So that's why don't touch the electrode or metal part of the electrode holder with skin or wet clothing. This you should keep it in mind. Keep dry insulation between your body and metal being welded or ground. So dry insulation should be there. There is generally for doing the welding operation, there is generally use some gloves types of things also are there, and there is some separate types of gloves and other things used for doing this welding operation. So this always keep it in mind. You should not touch the workpiece and electrode simultaneously at a time, and you should keep dry insulation between your body and metal being welded or ground. Then another thing also in this welding operation generated, that is generally ray. At the night times you can see, or generally where these types of welding operation is done, there you can see there is a thunder types of light coming out somewhere the night time, that types is sparking types of thing. So this is a very dangerous types of ray, you can say. This is generated due to this arc or a spark between this electrode and workpiece. This arc ray can injure your eye and skin. So that's for that reason always you should keep it in mind. You should wear correct filter shade of goggles during this welding operation, otherwise your eye can be damaged. So these are the different general safety precautions of this welding operation. Now in next lecture I will discuss about another arc welding process that is called GTAW, that means gas metal arc welding process. In this gas metal arc welding process or you can say GTAW, that means gas tungsten arc welding process. So in next lecture I will discuss about another arc welding or electric arc welding process that is called GTAW process. GTAW means gas tungsten arc welding process, or simply that is called TIG welding process. There also I will discuss the similar way, that means there also will be introduction of GTAW, there also will be setup of GTAW, there also will be what it's called principle of GTAW. Then if there is any special aspect of that welding operation is there or not. After that, at the end I will discuss about advantage, drawbacks or disadvantage and limitation, and if there is any safety precaution is required, that I will discuss. So in this way next lecture also I will discuss about another arc welding process.